You could say that interlocking concrete pavers came out of the rubble of World War II. In post-war Holland, there weren't enough clay pavers to rebuild city streets, so the Dutch began making concrete pavers. The Germans refined the technology and exported it to North America, where they found a quick road to success. Call it a concrete solution for paving. These pavers are solid, and the interlocking design disperses weight, easing the load on the road. To make these pavers, a conveyor belt delivers concrete sand to a weigh belt that weighs the coarse sand as it falls onto it. The weigh belt carries the sand forward, while another conveyor belt unloads stone chips to be weighed. These chips are no larger than 1/3 of a centimeter. The ratio of sand to stone chips varies, depending on the type of paver being made. The weigh belt transports the stone chips forward, along with the coarse sand. Both are en route to the skip hoist. They spill off the conveyor into the skip hoist, which is essentially a bucket on rails. Cables pull the loaded bucket upwards. It stops about 9 meters up, just above a big concrete mixer. A trapdoor opens and dumps the sand and stone chips into the mixer. 6 giant steel paddles mix and then rotate and mix again, while cement is added automatically through several nozzles on the side of this enormous mixing bowl. Making pavers is a bit like baking cookies. Too much or too little liquid in the batter, and it won't bake properly. Water is added until the consistency is just right. Nozzles also shoot a pigment into the mix to tint it. The mixture looks dry and crumbly, but the recipe gives it just enough moisture to form the concrete. Now a filling wagon spreads the mix over a steel mold containing up to 50 paver-shaped cavities. The mold press head applies 10 tons of vibrating pressure. This pulsating force compacts the mixture into the paver mold and removes any air pockets, which could weaken the pavers. Hydraulic cylinders lift the mold, leaving the pavers on the press board. The press board slides out, and the mold once again gets filled in and makes another 50 paver stones. It only takes about 10 seconds to mold, compact, and release a batch of pavers. The press boards filled with pavers slide into a rack. A hydraulic chain hoist lifts each board into a large holding rack. There, a special moving wagon called a finger wagon picks up all the boards from the rack in just one move. The electrical wagon moves along a rail to a curing kiln, where it's almost 38 degrees Celsius. The pavers actually generate the heat due to a chemical reaction from the combination of cement and water. About 12 hours later, the finger wagon carts the pavers out of the kiln. They're now 70% cured as a result of the chemical process that binds the cement, sand, and gravel, causing the pavers to harden. The rest of the curing will happen over the next 28 days. The pavers are now sturdy enough to handle, so 4 steel arms with rubber pads move in and straighten the stones on the board. These alignment arms are hydraulically driven. They arrange the concrete pavers so they interlock snugly. Now, hydraulic clamp arms lift the pavers off the board and begin to pile them up. They're making a cube of stone. This stacking machine is called a cuber. It packs 9 or 10 layers of pavers on top of one another to make this cube. The cube is actually called a bundle. It will be strapped and shipped out to the job site. These concrete pavers will be on the road soon, in more ways than one.
man has always wanted to fly, and the versatility of the helicopter has allowed him to reach unexpected heights. Plans for a helicopter were created with CATCHA 3D, design assisting computer software. It takes 700 hours of work between the drawing stage and assembly of the pattern. The helicopter is made of carbon fiber, a composite material lighter and stronger than steel, protected by 2 layers of green plastic. The fiber is cut with a blade controlled by ultrasound. They lay on several thicknesses of fiber to make the rear fuselage. The green light of a laser helps position the parts. Then with a heat gun, they apply a beehive web, which increases the solidity of the structure. But the carbon fiber is still soft. To harden, it must be washed under pressure for 10 hours in this autoclave oven at 177 degrees centigrade. The pieces exit the oven and head for machining. The door of the motor housing is kept in a cutting jig and is shaped with a manual shaper. Before installing the parts in place, they strike it with a resonance hammer to detect any faults. Next, the electrical harness is mounted on a pattern before being installed in the aircraft. This particular helicopter has 2,351 meters of wiring, but others can have almost 9 kilometers. The wiring will be connected to the flight instruments panel, the brain of the helicopter. This aircraft has 9,964 rivets fastened with a gun and a ram. They also apply a sealant to prevent the infiltration of corrosion, creating humidity. They now assemble the helicopter's rear fuselage. Piece by piece, the aircraft takes shape. They will install mechanical components later. The motor arrives. This one weighs 120 kilos and has to be carefully handled. Among the other parts to be installed is the circular plate on which the blades will be attached. Safety is primary. The screw nut holes are perforated, allowing the insertion of the brake cable. This tightly braided metal wire prevents the nut from loosening due to strong vibrations. Now they bolt on the 4 blades which make the helicopter fly. Weighing 41 kilos each, they're made of composite materials and an aluminum alloy. They're attached to the main rotor. The dashboard is installed in the cockpit, and all the wires are hooked up. Contact is established, and all is functioning properly. Nothing remains but finishing the interior of the craft. They install seats, safety belts, the consoles, bulkheads, windows and doors, as well as the trimmings. The helicopter is almost completed, but it still has to be painted. When done, the helicopter is towed outside the assembly hangar. Flight tests are performed to make sure that mechanical and electrical components are functioning properly. It requires an average of 110 days to assemble the 3,419 parts of a helicopter like this one, and they turn out almost 185 units each year. These 2.8-ton aircraft are capable of reaching speeds of 140 knots and flying at a maximum altitude of 6,096 meters.